Hello everyone, welcome to the channel. In this video, we will see a problem on work done by work energy principle. The problem states that a mass of 30 kg is projected up an inclined, up an inclined of 26 degree. They have the theta as 26 degree and it has been projected upward with the velocity of 4 meter per second. So the initial velocity is 4 meter per second as shown in the figure. If mu, that is the coefficient of friction between the plane and the package, is zero point 0.2, then find the maximum distance that the package will move along the plane. So we have to find the maximum distance S or D along the plane, and what will be the velocity of the package when it comes back to the old initial position. So here we have two cases. So first of all, write the given condition. So given data. Okay. So here mass is 30 kg. So mass of the package is 30 kg. So this is remain going to same, and its direction is projected upward. The theta is equal to 26 degree. They have given the theta is 26 degree with the velocity of 4 meter per second. That is v1 equal to 4 meter per second. And they have given mu equal to 0.2. Okay. So in the first case, so case 1, to find the maximum distance, that means we have to find the S, maximum distance that the package will move along the plane. Okay. In second case, what are we supposed to find? What will be the velocity of the package when it comes back to the initial position. Okay, see, so here now assume this is our initial first position, and this is our first position, and it is going in the upward direction in the second position. That means we have to find this distance, right? That is our first case. So in the second case, imagine our box has been rest. That means it has been covered the maximum distance. After that, after covering the maximum distance, it is going to come back to the initial position, that is first position, right? So in this scenario, the second case scenario, the data will be changed. We have to find the velocity. That means we have to find the velocity v2. Okay, so we have to find the velocity v2. We have to find velocity v2. Okay, so v1 will become 0 because after covering the maximum distance, the package is going to stop at some position. That position we have to find. It is going to stop, yes, right? After stopping, it will going to come back down as well. So at that instance, the velocity of the package will be initial, that is v1 will be equal to 0. Then we have to find v2. Okay, so we'll solve the problem. The first case. So in the first case, 26 degree. So we have a package. We have a package and it is being moved up in the upward direction. Okay, this is our first position and this is our second position. We are dealing with the case 1. So here the direction is upward, so the frictional force will be downward direction. Here we'll have mu dot n, so this will be a normal reaction and the weight will be acting downward. So it is given as 26 degree. So here also we'll have a 26 degree. So I'll be taking the angle with respect to x axis, that means 90 minus 26 degree, it is 64 degree. So this will be with 64 degree. Now we can resolve the component. So here we'll have 64, sorry, weight into 64. The weight of the box package was 30 kg. So 30 into 9.81. 30 into 9.81 cos theta. So we'll have a vertical force as well. 30 into 9.81 sin theta. Okay. So I hope I have written all the active force and reactive forces. Fine. So we have to find the distance. Okay. So this here will have V1, here will have V2 for the first case. Okay. Now we know that the normal reaction will be equal to the this one. Okay. 30 into 9.81 sin theta. So normal will be equal to 30 into 9.81 sin theta, that is sin 26 degree. So n will be equal to 30 into 9.81 into sine of 26 degree. So this gives me the value of 129.01. Okay, so 1012 Newton. This is the normal value, normal reaction value. Now we know that the block or the package is moving along the plane. Okay, that means in the x direction of the component. So the work done, or else by using work energy principle, we know that work done will be equal to change in kinetic energy. So change in kinetic energy, so work done will be equal to force into displacement or distance. So K1 kinetic energy 2 minus kinetic energy 1 initial position. So the what are the force acting in the x direction? We have two forces. One is 30 into 9.81 cos theta. Another one we have a frictional force as well. Okay, so minus 30 into 9.81 into cos of 26 degree into the x, that is a distance s, minus mu is we have taken as 0.2 into normal is 129.012 into s. This give equal to half into mass is 30 kg into v1 square. So v1 square, we know that v2 square is here rest, so it will become 0 minus 4 the whole square. Here v1 square is equal to 4. In the first case, v1 is equal to 4 meter per second. So we can use the calculator to get the value of s. So if I it's minus 30 into 9.81 into cos of 26 degree, it is minus 264.51 s minus 0.2 into 129.012 into this gives value 25.880 s into s into s. This is equal to, so 15, so 15 into 4 square, that is 16, is 240. So minus 240. So minus 264.551 minus 25.80. It is minus 290, because we have both these are SS, so we can add it. Minus 290.31 equal to minus, sorry, it is multiplied by S as well, minus 240, it will get cancelled. So S will be equal to 240 divided by 290.31. It gives me the value of 0.8267 meter. So this is the maximum distance the package is covered in the first case. So when the velocity was 4 meter per second, the maximum distance covered by the package is 0.8267 meter. Now for the second case, case 2, we will draw the diagram again. Theta equal to 26 degree. So here the scenario will get changed. Okay, so here the normal, this will be the normal reaction. Again, if you see now the direction is coming downward. Okay, so we going back to the initial position, this is downward. So the direction is downward, so frictional force will be in the opposite direction, mu dot n. So bit will be acting downward. Wait. Again, it's a 26 degree in the with the y-axis. I will be taking with respect to x-axis. It will be 64 degree. So we can resolve it as well. So same package. So 30 into 9.81 cos 64 degree. So one is a vertical component. 30 into 9.81 sine 64 degree. Okay, so the box is going back to the initial position. Now this is my first position and this will be my second position. Okay, so here the v1 will become 0. Here we don't know the v2, we have to find the v2. Now the distance between two boxes are 0.8267, two packages. Sorry, the distance between, it has covered the maximum distance of 0.8267 meters. So this will be the distance. We will be using this distance to calculate the velocity. Okay, so I hope you understood this free body diagram. Now again we the normal will be the same, because again normal is a vertical force. We can take the normal the same value. So by work energy principle, we know that work done is equal to change in kinetic energy. So force into displacement equal to initial, sorry, second position minus the higher lower position. So here force, what are the force again we are acting? The forces are, we have along the direction x direction. So we have two forces, one is 30 to 9.81 cos theta, but it is having the same direction as the package, so it will take it as a positive value. So 30 into 9.81 cos of 64 degree minus, what is the value of mu? So we have mu as well, so mu into normal. So we got the value of mu normal was something 129.012. So we can take the same value normal. So 0.2 into 129.012 into the distance which we have covered is 0.8267 meter. This will be equal to half into mass is 30 kg and v2 square we don't know, we have to find the v2 square minus v1 square is 0. Okay, so now so we can put it in the calculator, that is 30 into 9.81 into cos 64, sorry, cos 64 minus 0.2 into 129.012 into 0.8267. So we got the value as 85.3238 equal to, this will get cancelled, 15. So 15 v2 square. You have to find v2. So this will be v2 square will be equal to 85.3238 divided by 15. So v2 will be equal to root of this value, that is 5.6882. So v2 equal to 2.385 meter per second. So this is the final required answer when the block is coming back to the initial position. This will be the final velocity. I hope you understood this video. If you have any doubt, you can put it in the comment section. Thank you for watching.